A blessed day, everyone. Welcome once again to our new topic, which is the number systems addition. So here in number systems addition, we're going to solve first the binary numbers. So here is the addition of binary numbers. So we have the problem here, find the sum of the following numbers. So as you can see, we have here the given binary numbers. And we all know that binary numbers are different from the decimal numbers. The method of the addition is very much different. So we need to follow the binary numbers addition or the rules. Okay, so the rules in binary addition is 0 plus 0 is 0, same with the decimal addition. Next is 0 plus 1 is 1. Next is 1 plus 0 is 1. But the last part, which is 1 plus 1, is 1, 0. Okay, so it is different from the normal addition or the decimal addition. Okay, so why is it that we have the 1, 0 or 10 answer for 1 plus 1? Because we all know that binary number consists of two digits only, which is the 0 and 1. So once we completed the two digits here, 1 and 0, the next thing will be 1, 0. So that's the reason for this 1 plus 1 will give us 1, 0, or this 1. So let us proceed solving the binary number additions. Okay, so we have a given here first of 1, 0, 1, 0, 1 plus 1, 1, 0, 1, 1. So it will be easy for us to add this binary numbers by using my technique. I'm going to tell you later or in this procedure the easiest technique. So here, so 1 plus 1 is 0. So here the idea is that when we see a two pair of binary digits like 1 plus 1, two pairs of binary 1 digits will give us always a 0 value and will carry 1. Okay, because the answer here should be 1, 0. So we retain 0 and we put 1 as our carry here. Okay, so let us continue. 0 plus 1 is, or we have a carry here, 1 plus 0 plus 1. So we see again another pair. So 1 and 1 pair. So this should be a 1, 0. The same with the previous one. So we retain the 0 and we cancel, or we put 1 as our carry. Okay, so carry 1. So 1 plus 1, we have a pair already, plus 0. So 1 plus 1 is already 1, 0. Here, 1, 0. Plus 0 will also be 0. So we retain 0 and we carry the 1 here. Okay, let us continue adding. So 1 plus 1, we have a pair already. So we just ignore 0. Okay, we just ignore 0. So 1 plus 1 is a pair, so it will give us 1 0, but we need just to retain 0 and carry our 1 here. So carry 1. So here we have 3 binary ones. So we add 1 plus 1 will give us already a 1 0, 1 0 here. So 0 plus 1, we continue with that. The right side part, 0 plus 1 will give us 1, and the 1 here will be carried at the left side, this one. Okay, so and since there's no binary digits aligned with the 1 that we carried, we will bring down the 1 here. Okay, so our answer in our first binary addition is 110000. This is our answer for the problem 1. Okay, so let us have the problem 2. So we have in our problem 2, we have here the 1 1 0 1 0 1 dot 101. So we have a decimal value beside the binary digit. Okay, and plus 1. So 1 plus 1 1 0 1 dot 0 1 1. Okay, so we're going to add this one similar with the method that we did, having the binary digits without decimal points. Okay, so we add 1 plus 1 is already a pair, and it will give us 1 0. So we retain 0 here. We put carry 1 or place our carry 1 up and continue adding the next line. So 1 plus 1, the same that I mentioned, we can ignore 0. So 1 plus 1 is already a pair, so it will give us 1 0. So retain 0 and carry 1. So carry 1. So continue adding. 1 plus 1 is already a pair. This is a pair. So ignore 0 or just add 0. So 1 plus 1 will give us 1 0 and retain 0 and carry 1. Carry this one. So carry 1. So continue adding. 1 plus 1 is already 1 0, and 0 plus 1 is 1, and the remaining 1 here will be carried here. Okay, so continue adding. 1 plus 0 plus 0 will give us 1, so there's no carry here. Then 1 plus 1 will be 1 0, retain 0 and carry 1 here. So 1 plus 1 is a pair, so will give us 1 0 and retain 0 and carry this one here. And 1 plus 1 is a pair, and it's 1 0, so retain 0 and carry this one up here. And since there's no digits aligned with this one here, so you just bring down 1 here. So our answer now is, for this problem number 2 binary addition, is 100011000. So this is our answer for the problem number 2, binary addition. Okay, so let us begin adding this multi-layer binary additions. So we are going to apply the technique, the pairing technique that we did earlier. So we get the pair, so we have one pair and another pair. So by pair, if we have pairs, the uh, value or the result will be just 0. And we have two pairs, so we have the two carry here, two binary digits of 1 to be carried on the bottom part of our layer. So we continue, get the uh, pair of ones and a pair of ones here. We have two pair, so we carry already the uh, binary digits for the two pairs. So we have 1, 2, so the reason why we have two carries here. And the excess of 1 here will be just placed at the bottom as our result, 1. And we again continue by pairing. So 1 and 1. So 1 and 1 is a pair. 1 and 1 is a pair. So we carry the two pairs that we identified. So carry 1 and carry 1 here. And the remaining one here don't have a pair. So we bring down that one here and continue adding. Okay, look for another pair. This is a pair and this one is another pair, and we have an excess of 1 here, so we need to bring down this one. Okay, and the pair that we identified will be placed as a carry again here. Okay, two pairs and two carries at the top. Okay, so let us pair again. So 1, pair 1, pair 2, and pair 3. Now we have 3 pairs. So for sure, we will carry 3 binary ones here at the top. Okay, so we have a 3 pairs and no excess. So we place 0 for all pairs because there is no excess of 1. Okay, so then we continue adding by pairing. So pair 1 and 1, 1 pair, and this one has no pair, so bring this one at the bottom here, and we have 1 pair, so we have 1 carry here only. So since there is none here at the aligned addition, so we'll just going to bring down 1 here. So that's it, and our answer now for this multi-layer additions of binary numbers is 1011110. Okay, so this is our final answer for the problem number 3. Okay, so let us proceed with the addition of octal numbers here. So we are now in the addition of octal numbers. So we are tasked to find the sum of the following numbers for octal. Okay, our rules for octal is the number system for octal is will start from 0 to 7. So in octal there is no 8 value. Okay, so 8 is not allowed for octal. So only from 0 to 7 digits. Okay, so we start adding this octal digits of 1, 6, 2 plus 537. Okay, so we start adding 2 plus 7. So 2 plus 7 will give us 9, but octal is 8, total of 8. From 0 to 7, we have a total of 8 here. So meaning we already reached the complete cycle of octal. So we're going to subtract that whole cycle from 9. So 9 minus 8 will be 1, and bring down 1 here. And this 8 value as a complete cycle will be carried as one whole cycle. Okay, so 1, and it will be placed in our carry here. So carry 1. Now let us proceed with our next addition. 1 plus 6 plus 3 will give us uh, again 9. So 9. So same 10. Yeah, 10. So here 1 plus 6 plus 3 is 10, minus 8, which is the complete cycle of octal, will give us 2, and will bring down 2 here. And the complete cycle that we add for 10, having the 8, will be carried as 1. Okay, so let us continue adding. So 1 plus 1 plus 5 is now 7. Okay, so it is easy for us as long as we know the simple method of adding the octal numbers. So our answer for the first problem in octal addition is 7 to 1 in octal. So we can place a subscript base of 8 here to show that this number is in octal form. So we have here a guide if we want to use a shortcut method, and if we allowed to look at the addition table for octal numbers. Okay, so if we are allowed to look at in our table, to look at our table here, so let us check using the table. So 2 and 7 first, so we can select 2 and 7 here. 2 and 7 will give us 11. So the reason why we have here 1, and the another one will be carried here, 1. Okay, so continue adding. So 1 plus 6 plus 3 is 10. So we first look at the 6 in our table. So we may look here 6, and the next is 3, and this is 3. And let us check, and here is the meeting connection of 6 and 3, which is 11. So our answer is 11. 11 plus the carry 1 here will be 12. So 12. So 2 will be retained at the bottom, and 1 will be carried to the next line of octal addition. Okay, let us continue. So we get the number from 1, looking at the table, 1 and 5 here, 5, and look at the table, 5, and check which is the value of 6 here, 6. 6 plus the carry 1 will give us 7. Okay, so using this method here, the method without looking at the table will surely make you better in solving this octal addition. But if you are allowed to use the table, it is much easier. Okay, so that's how to solve without a table and to solve with a table for the octal numbers addition. Okay, so let us continue. Okay, so we have another number here. Okay, we have a decimal uh, values to be added. So let us add. So without a table first, 5 plus 6. 5 plus 6 is 11 minus 8, the whole cycle of octal. Minus 8 will give us 3. Okay, so 3, and the whole cycle of 8 here will be represented as 1. Okay, and it will be carried here as a whole cycle 1. Then add 1 plus 7 plus 5 will give us 13. Okay, 7 plus 5. Okay, 12, 13. So 13. So we have 13 minus 8. 8 will give us 5, right? Okay, so place 5 here, and we have one whole cycle equivalent to 1 to be represented as our carry 1 here, and continue adding. 1 plus 6 plus 4 is 11. So we place here 11 minus 8 will give us again 3, and we place 3 here. 3, and the whole cycle of 8 will be represented as 1 digit of 1 and be carried here. So 1 and bring down 1. And our final answer for the second problem for octal addition is 135.3. Okay, so again, place a subscript or base of 8 to indicate that this number is in octal form. Again, looking at our table, if we look at our table, 5 and 6, let us pair. 5 and 6 will give us 13. So bring down 13 here and carry 1. Then add 7 plus 5 is 12 plus 1, or base first here sa table. 7 and 5 will give us 12. Okay, wait, so 7 here, 5, 14. 14 plus the carry 1 is 15, so bring down 5 and carry 1 here. Then look for the 6 here. 6 and 4 in our table. 4, 6 and 4, and look at the result, which is 12. 12 plus 1 will give us 13, and carry 1, then bring down 1. So we still have the same answer by applying two different methods. Okay, so next, this is another octal numbers. Let us try. So we begin for the problem number 2. 3 plus 5 is 0 because 8 minus 8 is 0. So 0 here. So we already meet the one whole cycle of octal. So this is equivalent to 1 and should be carried here as 1. Then continue adding. 1 plus 2 plus 7 will give us 10. So 10 minus 8 is 2. So bring down 2 here and carry the whole cycle of 8 as 1 here. Then continue adding. 1 plus 4 plus 3 is 8. So 8 Same method, 8 plus 8 minus 8 will give us 0. So bring down 0 and carry 1 here, 1. Then continue adding 1 plus 4 is 9. So 9 minus 8 is 1. And this is a 1 whole cycle. So we place 1 at the bottom. Okay, and we place 1 as our carry here. And we continue adding. So 1 plus 5 plus 6 is 12. So 12 minus 8 is 4. And we place 4 here. 4. And we have 1 whole cycle of 8 here, which will be 1. And be carried here as 1. And continue adding. 1 plus 6 plus 4 is 11. So 11 minus 8 is 3. So we have 3. We place 3 here, and we have 1 whole cycle of 8 represented as 1 and will be carried here as 1, and continue adding. 1 plus 7 plus 2 is 10. So here 10 minus 8 is 2. Okay, so bring down 2 here, and we have a 1 whole cycle of 8 as 1. As 1 here, and place this as carry 1. And bring down that 1 here. Okay, so we have now our result here. Okay, so this is the third problem, and be able to solve for the result of the octal. And you can proceed by looking at the table. So it will be easier for you doing it your own. Okay, so let us now proceed with the next problem. Okay, now we continue to our hexadecimal numbers addition. So here, so we are now in the addition of hexadecimal numbers, and the same with the octal, hexadecimal has its own table. So it is the same way or method on how are you going to use this table. Okay, so let us proceed with the problems. So we have 2 problems for the addition of hexadecimal numbers. So we proceed with the problem number 1. So we have here, by the way, hexadecimal numbering is from 0 to 15. So 0 to 15 is a total of 16 numbers. Okay, and 16 represents hexa. Okay, but it is different because number 10 cannot be written as 10. It should be replaced as letter A. Okay, and number 11 should be written as letter B. Number 12 is letter C. 13 is D. 14 is letter E. And 15 is letter F. So this is the hexadecimal number system. Okay, so this is our table guide. So we can now proceed with the addition for the problem 1. So we add 7 plus 5. 7 plus 5 is 12, right? Okay, so let us check for the equivalent letter of 12 here, which is letter C. Okay, so we place C here. And we proceed. 8 plus F. So we look for letter F. So we place first 8 plus letter F. So what is the value of letter F here? So F is 15, right? So here, 15. So we add here 15. So 8 plus 15 is 23. 23, and with the same guide that I told you in our octal, so we need to subtract 23 by 16 because hexa is 16. The whole cycle of hexa here is 16. Okay, so we subtract it by the whole cycle of 16 here. So 13 minus 6 is 7. Okay, so 7, we place 7 here, and we already have a whole cycle of 16, which is equivalent to 1 cycle, and we use this as our carry, this one whole cycle. Okay, so we carry that as 1 and continue adding 1 plus 9 plus e. So let us first place 9 plus e. Letter e is this one, and the value is 14. So we add 14, then add. So this is 13, so 23. Okay, 23, and we subtract that by the whole cycle, which is 16 hexa, and we start subtracting. So 13 minus 6 is 7. Okay, then plus our carry 1. Our carry 1 will give us 8. 7 plus 1 will give us 8. Okay, so let us proceed. So we have 8 here and a carry of 1 because we already meet the one whole cycle of hexa, which is 16. That is why we have a carry of 1 here. And we continue adding 1. We stand by the 1 for a while, then we just proceed with c plus 6. C is 12. C is 12 here in our table, 12. So 12 plus 6. So 12 plus 6 is 18. 18 plus 1, we could add plus 1 as our carry, so 19. So we can now subtract 19 to 16, total of 16, right? So we have 3, remaining of 3, and we place 3 at as our answer here, 3, and we carry 1 because we have a one whole cycle of 16 here, this one. Okay, so that is represented as 1 whole carry. So we proceed with b plus 4, and we later add that 1. So b in our table, b is 11. So 11 plus 4 plus 1 is now 16. Okay, so 16 minus 16 since is 0. 16, our answer will be subtract by hexa, which is 16 will give us 0, and place 0 here, and be able to meet the whole cycle of hexa. So this will be represented as 1 and as carry as 1, and continue adding a plus 2 plus 1. So we place here a is 10 here, 10. So we add 10 plus 2 plus the carry 1. Okay, so we have 13 here. So 13, we look at the table, 13 is letter D. Okay, so letter 13 is letter D. We place it here, letter D. Okay, so we have now our final answer for the problem number 1 for the addition of hexadecimal numbers. So this one, so D0387C for the result of problem number 1. Okay, we solved for the problem number 2 of hexadecimal addition. Okay, we remove that, we clean our slide, and we proceed solving. Okay, we start with letter B and plus A. So this is letters. We look at our table. So B here is 11. So we place here 11 plus what? Letter A. We look for the letter A here, and the value, equivalent value is 10. And that is total of 21. And we're going to subtract that with hexa, which is 16, and 21 minus 16 is 5. So we bring down 5 here, and we already meet the whole cycle of 16, which is equivalent to 1, and this will be carried as 1 here. Okay, then continue adding 8 plus 7. So 8 plus 7 is equal to 15. So we cannot just bring down 15. We need to change that to letters. So our 15 here is equivalent to F. Okay, but right now, then we add 1. We add 1. Our carry here, 1. So 15 plus 1 is 16. So we subtract 16 minus 16 will give us 0, and bring down 0 here, and 1 cycle of hexa, and we place that as our carry of 1, and continue adding A plus 9 plus 1. So A is, we look for the value of A, which is 10. So we place 10 for A, and 9. 10 plus 9 plus 1 will give us 20, minus 16 will give us 4. So bring down 4 here, and carry the whole cycle of 1 here of hexa, and place it here as your carry. Then continue adding F and C. So we look for the value of letter F. So F is 15. So we place 15 here, and letter C. Letter C is, we look for the value of letter C, which is 12. Place it here. Then we add the carry of 1 plus 1. So plus 15 plus 12 plus 1 is 28, minus 16 will give us here, yes, correct. So will give us 2, 12. Okay, so yes, so 12 cannot be placed as 12. It should be reflected as letter. So 12, we look for the value of 12 here, and the letter equivalent is C. So we place letter C here for number of 12. Then we have a whole cycle of hexa equivalent to 1. So we need to carry that 1, and there's no digits here to be added. So just bring down 1, and we able now to come up with our final answer for problem number 2. So our answer for hexadecimal addition for problem 2 is 1C405 here. Okay, so right now we uh, already knew how to solve different number systems addition from binary addition, octal addition, and hexadecimal addition. Okay, if you want to use the table for getting your answer, solving for your answer, you may do so, but this is the best method that you can solve the given number systems in addition without using the table. Okay, so that's it. We're done again, and we have another learning lesson, a very uh, fruitful lesson for you. So thank you so much, and see you next lesson.